Alright, this is Geometry Chapter 2, Section 5, Reasoning in Algebra and Geometry. Okay, so this is going to talk about a lot of properties that we've talked about before, and then in terms of equality. And then we'll talk about the same type of properties of congruency, and then we'll get to do our first proof. Yay! Don't you feel so lucky? So, a couple properties that you guys already know how to do. These are algebraic properties. And the reason why they're called algebraic properties is because they're called algebraic properties because they involve variables and adding and subtracting things. So we have the addition property of equality, and the addition property, this is how I write it, of equality just means that if I add something, I got to add it to both sides. So A equals B. If I add something to one side, I got to add it to the other side. And the equality sign remains true. The subtraction property of equality, and I'm going to go through these real quick because you guys have seen these before. If I have two numbers that are equal to each other, and I subtract one number from one side, I got to subtract that other number from the other side. What I do on one side, I do to the other. Alright. What did I do the first one? C minus. What I do on one side, I do to the other. Multiplication property of equality. If I have A equals B, if I multiply by a number on one side, then I do the same thing on the other side to maintain equality. What I do on one side, I do to the other. You guys know these already, hopefully. If you forgot, remember it, please. Division property of equality. If I have two numbers that are equal to each other, if I divide one side by the number, I got to divide by that same exact number in order to maintain the equal sign. Of course, given that c doesn't equal 0 because you can't divide by 0. Okay. Other properties that you've been exposed to, reflexive property, and we're actually going to see this quite a bit in proofs, so we should get used to this. This is the reflexive property of equality. And all it says is that any number or letter or value or quantity equals itself. And that's it. Anything equals itself. 5 equals 5, 2 equals 2, 3 equals 3, 4 equals 4. Anything equals itself. Then we have the symmetric property of equality. And what that says is that if A equals B, then B equals A. So for an example, if 6 equals 1 plus 5, then 1 plus 5 equals 6. We can flip the order across the equal sign, and the equal sign still remains true. Transitive property of equality. We've also seen this one as well. I'm going to call it TPE, and it's going to be important that you say the transitive property of equality, and that says this. If A equals B and B equals C, then A equals C. So numerically, we can go with the 6 again. 6 equals 5 plus 1, and 5 plus 1 equals 3 plus 3. Then I can say 6 equals 3 plus 3. Right? If A equals B equals C, then A equals C. Transitive property of equality, TPE. We will be seeing this quite a bit in our proofs. We also have the substitution property of equality. I just call it sub, and I use it for transit for equality and congruency. And it says that if A equals B, then I can substitute B for A in any situation. Then B can be replaced by A in any situation. All right. B can replace A in any situation. All right. Real quick, you guys have seen these before. You guys have used these before many, many times. We have the distributive property of equality. And the distributive says that if we have some number multiplying, let's see, some expression in the parentheses, then that everything inside the parentheses is going to be multiplied by everything outside the parentheses. So this is going to be A times B plus A times C. It also works with subtraction. If we multiply some expression where it's being subtracted within there. Okay. They want us to solve this expression and to justify it. When they say justify each step, you're going to explain the property that you used in order to solve. So, it says given that AB bisects RAN. So we have angle AB here, or ray AB, and it's bisecting angle RAN. So I know that angle RAN is equal to RAB, sorry, is equal to BAN. Okay, I'm just going to say that's given to me. That's my justification. I know that angle RAB is equal to x because of the figure of the drawing, and angle BAN is equal to 2x minus 75. And the reason I can say that is because I use substitution. I substituted 2x minus 75 for BAN, and I substituted x for RAB. I'm going to add 75 to both sides, so it's going to be x plus 75 equals 2x, and I'm going to use the addition property of equality. That's my justification. That's why I did it. What I add to one side, I have to add to the other to maintain equal sign. Then I'm going to subtract x from both sides, and I get that 75 is equal to x because of the subtraction property of equality. I subtracted x from both sides. The x cancels here, and 2x minus x is x. So then my answer is going to be 75 equals x. Okay, so we're solving for equations like we've always done. We just have to justify what we do over here. Now we have properties of congruence. And property of congruence says that if I have the same properties that I had before with equality, then I can transfer them into congruency. They're the same properties. So we talked about before the reflexive property of equality, we also have the reflexive property of congruency. So I'm going to say reflexive prop. And this time I'm going to put the congruency symbol here, so we know that we're dealing with congruency. So there's two of them. There's one for segments and there's ones for angles. So I have any segment is congruent to itself. I can also say that any angle is also congruent to itself, right, by using the reflexive property of equality. We also have symmetric property of equality. Of congruency. Also for segments and for angles. Symmetric says that if I have two segments, AB, and it's congruent to CD, then I can say that CD is congruent. Actually, I say then. CD is also congruent to AB. I can also use it for angles. If angle A is congruent to angle B, then I can say that angle B is congruent to angle A using the symmetric property of congruency. Okay. We also have the transitive property of congruency. I called it TPE for equality. I'm going to call it TPC for congruency. Transitive property of congruency, or TPC. It says this, and it works for segments and it works for angles. So for segments, segment AB is congruent to segment CD, and segment CD is congruent to segment EF. Then segment EF is congruent to segment AB. If A equals B and B equals C, then A equals C. It also works for angles. Whoa. If angle A is congruent to angle B, and angle B is congruent to angle C, then angle A is congruent to angle C. Using properties of congruence. So for 2A, they have write the property of congruence or equality that justifies going from the statement to the second statement. So this one for A, it says that AR is congruent to TY. Then it says that TY is congruent to AR. That is the symmetric property of congruence. B, it says 3 times the sum of x and 5 is equal to 9. Then it says 3x plus 15 equals 9. That's the distributive property. And in C, it says 1/4 x is equal to 7. And then it says x equals 28. That will be, we multiplied 4 on both sides, right? So that's the multiplicative property of equality, or multiplication property of equality. Okay. We're going to use all of these properties and all of these rules, all of these things in order to justify uh, our proofs. So we finally get to write a proof. And according to the book, it says a proof is a convincing argument that uses deductive reasoning. An argument, I'm going to say logical argument. A logical argument based on deductive reasoning. We already talked about what deductive reasoning is, using facts and rules and justifications to make our argument. Okay. We're going to do something called a two-column proof. And basically a two-column proof we have one column this way, one column that way. The first line is going to say, let me change it a little bit. Statement, I usually write S. Reason, I usually write R. We're going to number these, the number of steps in order to prove our proof can vary. Our last line is always going to be what they want us to prove. Our first line is usually what they ask us to give, or what they've given to us. So our first line is usually given to us. And our last line is what they want us to prove. What you prove. So, shall we? All right, let's go through the first one here in the problem. So, we have this scenario over here. We have that the measure of angle 1 is equal to angle 3, and they want us to prove that AEC is equal to DEB. So let's take a look-see over here. Notice that we have 1 and 3 are the same, right? Notice that AEC is a combination of 1 and 2. Notice that BED is a combination of 2 and 3. So in order for us to do this, in order to prove that those two guys are the same, we have to say that both of the angles, 1 and 3, are both added with 2. And since they're both added with the same thing, then they must be true. And we have to use various proofs to prove that. So, the first line will always be our given. Angle 1 is equal to angle 3. That is given to us in the problem. That is given to us in the picture. Number 2. Angle 2 is equal to itself. Reflexive property of equality. So we have this angle BEC, or angle 2. We can always say that it is equal to itself. It's always important to establish that something, if we're going to add it to something, usually most proofs say that it's equal to itself in order to say that this thing, since it's equal to itself, can be added to whatever I want it to be added to. So we're going to use it to add to the other two angles. The next thing we're going to do is say that angle 1 plus angle 2 is equal to, is equal to angle 3 plus angle 2. this thing that we have that's equal to itself, if we add it to both sides, so look at our first line. So our first line is 1 equals 3, and then we added 2 to both sides. 1 plus 2, 3 plus 2. Whatever we add to one side, we add to the other. So this is the addition property of equality, which says that if I add the same thing to both sides, the equal sign remains true. Okay. Step number 4, it says that angle 1 plus angle 2 is equal to angle AEC. And it says that angle 3 plus angle 2 is equal to angle DEB. That is because of the angle addition postulate, and we learned that earlier in earlier sections. Everything that we've learned in previous chapters and sections are fair game in any proof for the rest of the course. Angle addition postulate. I'm going to say angle add postulate. Angle addition postulate. What does that mean? That means that the bigger angle, AC, is comprised of adding the two smaller angles, 1 plus 2, and the bigger angle, DEB, I think it's DEB, right? Yeah. Angle DEB is comprised of the smaller angles 3 plus 2. We're almost done. The last step, notice that AEC equals 1 plus 2, right? DEB equals 3 plus 2. So we can substitute AEC for 1 plus 2. And we can substitute DEB plus 3 plus 2. Which is exactly what they want us to prove, and we did it by substituting. We substituted AEC plus 1 plus equals to 1 plus 2, and we substituted DEB into 3 plus 2. This is a 5-step proof. Okay, we said that angle 1 equals angle 3 because it's given to us. Then we were able to say that this section, angle 2 is equal to itself because of reflexive property. They were able to add angle 2 to both sides from line 1 using an addition property of equality. We were able to use the angle addition postulate to say that angle 1 plus angle 2 equals angle EC, and that angle 3 plus angle 2 also equals angle DEB. And then we were able to substitute those angles for 1 plus 2 and 3 plus 2 respectively using the substitution property, and we are done. The proof that they give us down below, they give us this line segment here. A, B, C, and D. They tell me that CD and AB are congruent based off of the graph. They say that AB is congruent to CD, and they want us to prove that AC is congruent to BD. Okay, so we're going to write a 2-column proof. Oh lordy. Cannot write a straight line with this thing. It's worse and worse every single time. I have my statement. I have my reasoning. My first line is always going to be my given, angle B, AB rather, segment AB. Okay. Segment AB is congruent to segment CD. That is given to me. We can also say that segment BC is congruent to itself. That's reflexive property of congruency. Then we can say this. We can't add congruency statements. We can only add equality statements. So we're going to have to convert this from congruent to equality. So I can say BC is equal to BC. And BC is equal to BC. And I can say also that AB is equal to CD because of definition of congruency, or definition of congruent segments. And which says this: if something is congruent, then they're equal, and vice versa. If something is equal, then they're congruent. And we have this definition given to us in earlier sections. Now that I have them as equal segments, I can add or subtract them. I can't add and subtract congruent statements. I can only add and subtract equal statements. So I can say that this segment that's reflexive to itself, I can say that angle, or segment rather, AB plus segment BC is equal to, actually let's use the same thing. Let's use the same logic as the angles so as to not confuse. So we can say that segment AB plus BC is equal to segment CD plus BC. And we do that by using the segment addition postulate. So I call it SAP, segment addition postulate. Segment addition postulate. I added BC to both sides, the equal sign remains true. And then number 5, I can say that AB plus BC is equal to AC. I can say that CD plus BC is equal to BD. That is because of, this is not segment addition postulate, I'm sorry. This is segment addition postulate. I'm skipping steps in my head. This is because of property of addition. Addition property of equality. My fault. I'm skipping steps in my brain. Okay. After that, I can say that AC, this is BD, that AC is equal to BD, and I can do that because of substitution. And then my last step is to say that AC is congruent to BD. Definition of congruency, which says that if they're equal, then they're congruent. So first step, I got my stuff that's given to me. Second step, BC is congruent to itself. Third step, if they're congruent, then they're equal. So BC is equal to BC, AB is equal to CD. Fourth step, I add BC to both sides, addition property of equality. Fifth step, I said that AB plus BC is equal to AC, and CD plus BC is equal to BD, segment addition postulate, which says that the two smaller segments is equal to the bigger segment. I can substitute AC for AB plus BC. I can substitute BD for CD plus BC, and I can say that AC is equal to BD because of substitution property of equality. And then lastly, if something is equal, then they're congruent. Therefore, I can say that AC is congruent to BD. Definition of congruency. Okay, those are those sections, those proofs. I hope you have a great rest of your day.